So the voice and the screen is visible to you all. So very good evening to all of you. How are you guys? Make sure the screen is visible to you and I'm audible to you. First, just write this thing in the chat box if I'm audible and visible to you. Okay, sure. So every one of you screen is visible and I'm audible. Okay, got it. So now, firstly, tell me how are you guys? Are you fine? Good evening to all. At least say good evening here. Okay. So here we are with our gravitation lecture number 3. Good evening, Bharat. Uh, so it is the continuation. Yeah, good evening to all. Good evening, Ishwar, Lakshmi, Anita. Yeah, K. Jhansi Rani. So good evening to all. Rashmi, good evening. Hi, sir. Anvisha, Ganesh, and M. Good evening to all. Good evening to all. So, so gravitation we are dealing with, and it is the continuation of our lecture series in gravitation. Lecture number 3 we are having. Okay. So today, what we are going to learn, it is the firstly we will do some recall, okay, that we have done in the previous lecture. Then gravitational field intensity due to different bodies, in which 3 of them we have covered, like for point mass and for uniform hollow sphere, or you can say thin spherical shell, and for solid uniform sphere. So these 3 structures we have done. Okay, these 3 bodies we have seen the how the gravitational field intensity varies, and then okay. So now here we are with uh, the another that is left over. Now the acceleration due to gravity upon Earth's surface that we are going to deal today. Okay, so this is it for today. Now let's get started with it. So firstly, in the recall part, we have term we have learned a term gravitational field. ग्रेविटेशनल फील्ड का कॉन्सेप्ट कहाँ से आया? इट इज केम फ्रॉम द फील्ड थियरी. एंड व्हाट अ फील्ड theory says that because every mass is attracting the another mass in the universe, if there is no contact present there, then how is this possible to attract some mass which is present at some distance, which is not in contact? Okay, if you are pulling something, if you are pulling your friend or you want to push him, you have to make the contact now. But this mass, the Newton law of gravitation says that this mass, any mass present in the universe, attracts the another mass which is a far distance away from it. And the Newton law of gravitation is, uh, I think, it is valid for intermolecular distances up to the interplanetary distances, which means if you are here as a mass particle and there is a another mass particle which is present on moon, so you and that particle applying a force on each other, okay, which means there is a sort of connection in there. Because there is no contact, then how is this force has been applied to another mass? Okay, it is possible due to this explanation is done by this field theory, which is the gravitational field. Now, what is happening? There is a mass, okay, let's say here this is a mass, okay. So what field theory suggested us that this mass is not exactly going to exert the force, okay, not directly exerts the force, okay. Then the field theory says that, what is the statement for field theory? That every mass particle present in the universe, it creates its gravitational field surrounding itself. So here's the mass m, and there is a gravitational field has been created. This is the gravitational, this is the gravitational field, okay, of mass m. Let's say this is mass m, okay. So when this field has been created, so you can say if this is the point mass and this is the field created by it. Now if any another mass particle, let's say m dash, came into contact to this field, it is not directly contact with m, it is not making a direct contact with m, but it is making a contact with its field. So this field is going to exert a attraction force of attraction onto this mass, okay. So this another mass, let's say m dash, experiences a force. So this is the force exert exerted by force exerted by field, gravitational field, gravitational field. Got it? So what is the theory? Theory is like we have mass, so mass cannot directly be in contact with each and every mass. So, but there is a force experienced by that mass particle. So, how is it possible? This mass, every mass creates a gravitational field around it. Okay. And then this gravitational field, uh, whoever comes into this gravitational field, the another mass particle will experience a force. Okay. So it satisfies the statement of gravitational force that it is a non-contact force, which means you do not have to make the contact with that particle which is exerting a force, like our Earth. Earth is attracting the asteroid and meteoroid. Earth has attracted the moon also, but there is no direct contact. So how it is possible? Our Earth is behaving as a point mass with a mass concentrated on its center, and it creates its gravitational field surrounding to it, and that another mass particle like moon or any other asteroids or meteoroids came into contact with this field will experience a gravitational pull towards the center of Earth. Why specifically the center of Earth? Because we know that the force of gravitation is a central force which acts along the line joining the center of point masses. And center of point masses is nothing but the point where the center of mass of any particle lies. Okay. Newton law of gravitation is valid only for the point mass particle. Got it? So that is why in each and every symmetrical object, we can consider it to be a point mass. And the whole mass lies on the center of it. Okay, got it? I hope you are clear with this gravitational field type of thing. Now, in the recall part, we have done the gravitational field intensity 4-point mass. So for point mass, it is I is equals to gm over r square, where m is the mass of this point mass. Okay. So let's say this is the point mass, and at a distance r from its center, okay, there is a point P. So the gravitational field intensity I at that point P is nothing but gm over r square. In vector form, you can write it as how? In vector form, it is I vector is equals to minus gm over r square dot r cap. Okay, r cap is the unit vector of r vector. R is the position vector where the point is positioned. Okay, with respect to the particle. Got it? Why this minus sign? Minus sign is saying that it is the attractive force. This is the attractive in nature. Attractive in nature. Okay. Now for the hollow mass, we have seen it. For hollow sphere or thin spherical shell, or it is a thin spherical shell. Okay. So for that, for thin spherical shell, if a point lies outside, if a point lies outside the sphere, okay, so the point mass, the hollow sphere, like this is the hollow sphere, and if a point is lying here, this is the point P here, at a distance r from its center, okay, then shell theorem we have studied. What is the first statement of shell theorem? Shell theorem says that if any mass particle, okay, if any hollow sphere or thin spherical shell having a point outside of it, then it will behave as the point mass. Okay, and the scenario will become the same, that a gravitational field intensity for a point mass. Okay, so this hollow sphere will behave as a point mass small m. At a distance r, there is a gravitational pull at this point. So the intensity would be gm over r square. Same for the point mass. In vector form, it is also the same. Now what is the second statement of shell theorem? Shell theorem says that any point lies inside the thin spherical shell or your hollow sphere. This is the hollow sphere, and this is, let's say, this is the point P on which we have to calculate the gravitational field intensity. So this point P has equal and opposite gravitational forces which balances each other and neutralizes each other. So the net intensity at point P inside the hollow sphere will be 0. Okay. So here you can say that I is equals to 0 for point lie inside. And inside means anywhere inside the hollow sphere, not specifically the center, not specifically the circumference. It is anywhere inside the sphere, but the condition is that point should be lies inside the sphere, inside the hollow sphere or thin spherical shell. Okay. For uniform solid sphere, we have seen that if a point lies outside it, it will behave as a point mass. So the same for it, I is equals to gm over r square. But if the point lies inside the solid sphere, now here, this is the solid sphere. It is a solid sphere, and this is the point P here. This is point P. Okay. So you can consider this solid sphere or this point. My God. This is the solid sphere that we have. So we can consider a sphere so that the point P lies on the surface of it. So this another dotted sphere will behave as a point mass, and this point P lies outside that sphere at a distance exactly equals to the radius of the inside sphere. So this is the same case when this point mass particle, this sphere behaves as a point mass, and this point P present here at a distance, this is point P, and this is at a distance, this is the point mass m dash, because it is not the total mass of the sphere. So here it will exert a force same as the gravitational field intensity for point mass lies outside, but the expression is different here. The expression is I is equals to gmr over r cube. One of the student has mentioned in the yesterday class that I have forgottenly, mistakenly, I have write it as gmr over r square. Although in the expression also it is clearly visible that it is r cube. Okay. So I am correcting myself here and sorry for that mistake. It is r cube, not r square. So from here you can say that a graph variation you will see the intensity variation with distance r. With r, you can say that for center, if you put r is equals to 0, this is for the inside and center lies inside. So put r is equals to 0. So I is equals to 0. It moves linearly with I because I is directly proportional to r. This is the linear variation. And again, it behaving on the outside point, it is 1 by r square, or you will see it is 1 by r square. Okay. So it will go like this, curvilinear. Okay. As r moves to the infinity, then I will become 0. So maximum value you will have at that radius, at the circumference, at the surface of that sphere. This is the maximum intensity. Okay, got it? Now, uniform ring we have to do for it. Just give me 10 seconds. Na? Okay. So sorry for the disturbance. So here we are with uniform ring. We have to find out the gravitational field intensity at this point. At this point P, we have to find out the gravitational field intensity. And you guys pay attention to this derivation. Okay. This is your, let's say, uh, this is y-axis, this is x-axis, and this is z-axis. Okay. So here will be the minus z. So I have taken a isometric view of it so that it is more detailed view that you will have. Okay. So you will, now you can relate it, na? This is a 3D, and this ring is like this, and this point is coming outward to it, and here you have to calculate the gravitational field. Okay, got it? So let's just start with the derivation. So what you will have here, you have a uniform ring. Okay, it is also a continuous mass, but is it like a point mass? No, it is not like a point mass. So we can assume that for that type of derivation, the very first thing that you are going to do, you can assume it. Let me write it. First, we will assume, we will assume that this ring is uniform ring, uniform ring is made up of infinite point masses. Okay, so we can consider this ring to be made up of point masses like this. This ring is made up of these point masses, and from point mass we can calculate the gravitational field intensity. So what we are going to do, we will take one point mass, calculate the gravitational field intensity at point P, and then we will sum for the total mass. Okay, then we will add all the dm's present here. Okay, got it? Now, so this distance, this orange color distance that you are seeing, you will assume it at this, you can assume at small r, or here the point mass having mass dm. D means very small mass, differential mass. Differential mass is very small, infinitesimal small. Okay, so it is very small, so it will behave as a point mass. Okay, this is the point mass, this is point P. So what is the gravitational field intensity? We will calculate it easily. Let's say this angle is theta. For your clarification, this is the ring na. Okay, this is the ring, this is r, ये dm हो गया, this is point P, and this is angle theta. So here this angle theta is this. Okay, now the gravitational field intensity is a vector, so it will act along the line and towards the point mass. So the direction of it will be like this, or in this expression you will see it is like this. So the point mass is very small, so the field intensity created by it is very small also. Okay, so this di is here, and this distance is nothing but small r. Okay, let this distance, the distance of center origin to the x-axis where the point is present, to be x. Okay, and this y-axis distance, we can consider it to be the radius of this ring. Okay, now if you will see this expression, this is the ring, this figure you will see, this is the ring, this is point P, and this is the line of field intensity. So what we are going to do, we will resolve it, because this angle is theta, we will resolve it in y-axis and x-axis. So this is the component di sine theta, the vertical component, and the horizontal component will be di cos theta. Okay. Now, if you will consider a point mass just below it, you will see that there is a line joining it. In this direction, the di will act. If you will resolve it, you will have di cos theta in this direction, again di cos theta, or di sin theta in negative direction, vertically downward direction. Got it? Let me just show you in a detailed view. Let's just black the screen. Okay. So here the ring you have, here is the ring. This is the center of ring. This is point P here. And this is the line joining from dm mass to this point. This is the direction of field intensity, di. It is angle theta. So this and this are the component. This component is nothing but di cos theta. This component is nothing but di sin theta. If you consider this point as a point mass, this point, so you will connect the line. Again, you are going to resolve it. So one component will come in this direction, horizontal direction, and one will come in the vertical direction. When you move at this point, which is just below this line, you will connect to it, and then you will resolve this because of the symmetry, angle will be same. So you will have di cos theta here, but now the vertical component has changes its direction. It will lies downward direction. So all the particle at present at this below the line connecting to the point P will have a component in downward direction, which is di sin theta. So the vertical component here, di y, is equals to 0, because for the upper half, the vertical component in positive upward direction, and for the below half, it is in the negative direction, downward direction. So this will cancel each other. So vertically, we do not have any kind of intensity. We will have only intensity in x direction, which is nothing but di cos of theta. Now, how do we write di? So di is nothing but, from the formula, remember, I is equals to gm over r square. So di is g, not m. It is dm, because mass of the point mass here is dm. G dm over r square. Got it? So what is the net? So you are clear with this? It is g dm r square. Now move back to our original slides. So from the above discussed thing, you can say that here di is equals to what? G dm divided by r square. This is equation number 1. Now the net intensity in y direction equals to 0. I have taught you how it is becoming 0. This is the vertical component, this is the horizontal component. Okay. So di sin theta net is equals to 0. Now the total, so the net intensity is in the x direction. Okay. In x direction, what is the intensity? It is di cos theta. Okay. So if we integrate this, what do we have? We have I net. So I net here is integration of, put the value of di. It is GdM divided by r square into cos of theta. Now, if you see this triangle in which this angle theta is coming, so this have radius r connecting to this point, point P. Here is the angle theta. This is nothing but radius. This is x that we have assumed, and it is small r. So cos theta from this triangle would be what? X upon r. And x is a fixed distance from each and every mass particle. It is fixed. So I net here is, put the value of cos theta, integration of g dm divided by r square, you multiply with x over r. Okay. Now you can say that I net here is integration of g dm divided by g dmx divided by r cube, x and capital G are the fixed quantities, so they can be taken out of the integration. Okay, so integration means summation. We are summing up all the intensities. Okay, it is the summation. We are adding all the dm masses intensities in x direction. That is why this symbol has been used. Okay, integration. So it is g dmx. So you can, for any constant, you can taken out of the integration. So g x upon r cube can be taken out. It is dm. So integration of dm means sum of all the point masses. Now you guys will tell me that if I sum all the point masses that I have considered, because in the first assumption I have taken that this uniform ring is made up of infinite point mass. So if one point mass has a mass dm, and if I add all these infinite point masses, then what is the total mass? Tell me. Write this thing in the chat box. This ring is made up of infinite mass particle. If I add them one by one, all the mass particle, then what the mass I will get? Is it the mass of total ring? This is the total mass of the ring or something else? If it is the total mass of the ring according to you, then write 1, and if it is another thing, then write 2. Just make it. I'm waiting for your response. Rajesh is here, na? Bhavna and Anita and many more. So write this thing in the chat box. Is it 1 or 2? 1 means total mass is the total mass of ring. If we connect all the particles. Write this thing in the chat box. And if you are not clear with this, just let me know, na? I think Hitashri is also here. Bhavna, Anita, Anvesha, Jhansi, Saroja. Write this thing in the chat box. Do I consider sum of all these infinite mass particle that I have considered to be zero, total mass of the ring or not? Tell me. Okay, are you clear with this concept? Just write yes or no. I will re-explain it for you now. Until you didn't get it, then how you are going to answer to my questions? So just let me know if you are getting this. Okay. So This ring, this is the ring here. This ring I have considered it to be made by infinite point mass. This is dm, 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 and so on. Okay. So if I add these all dm, what you will have? You will have as, tell me, the total mass of the ring is capital M. Now, if you add these dm mass particles, then what you will have? You will have the, yes, yes, Anvisha. You will have capital M, total mass of the ring, because this mass particle is a part of ring, na? So if we add them one by one, we will get the total mass of the ring. Simple. Okay. So I can replace this integration of dm. I net here is gx by r cube dm. Integration of dm means summation of all the particles, which gives you capital M. So I net we have here, I net is equals to gmx divided by, and if you put the value of r in terms of capital R and X, so R is the hypotenuse of this triangle. So it will equals to square of R plus square of X. So it is R square plus X square and raised to the power 3. This square root has a power of 1 by 2. So I net here is gmx divided by r square plus x square raised to the power 3 by 2, because a raised to the power 1 by 2 to the power 3, and these power got multiply. So you will have a raised to the power 3 by 2. Got it? So this is the final expression that you guys will have. This is it. Now, hope you are clear with this. Just write it down or take the screenshot. Now we will see that at what point this intensity would be maximum. Okay. So we will have I is equals to G capital Mx divided by R square plus X square raised to the power 3 by 2. Okay. So if you want to calculate the maximum intensity, then here what thing you can vary? This is the ring. This is the center of ring. Okay. And here is a point P, which is at a distance x. So you can vary this x. You can take this point here, here, or here. So here the variable is this point P. Sorry, this distance x. So for maximum, for I max, differentiation of I max, I with respect to x, put it to be 0. Okay. Got it? Now, let me know one thing. Are you guys facing trouble with this differentiation and integration? Like, I think because when you have started learning physics in your 11th, so the chapter number 2 is itself mathematical tools. So there will be the information about integration and differentiation, maxima, minima, and all. So if you guys have that information, it is fine. Otherwise, you are finding trouble in this expression, na? So are you up to this? So fine, sir. Okay. Which means you have the knowledge of integration and differentiation. No? Just write yes. Okay, okay, okay. Okay. Now, I was worried about because if integration and differentiation has a problem, then this expression would have no point to discuss. Okay. So do this differentiation. It is a differentiation of dy by dx if y is equals to, yeah, I can explain what is maxima and minima. Just a second. Look, if this is the curve, okay, if this is a curve, and let's say this is the curve of intensity with respect to x. Got it? Now, what is maxima and minima? Firstly, we are interested in maxima, okay, because here we need the maximum, okay. Now, if you will see, if you will try to find the slope at this point, so what is the slope? What will be the slope? You can draw the lines perpendicular to x-axis and perpendicular to y-axis. This is, let's say, I dash. This is, let's say, x dash. So what is the formula for slope? You can draw a tangent passing through that point. Okay? So m here equals to tan theta, and tan theta is nothing but, yeah, बिल्कुल सही. Maxima is the highest point and minima is the lowest point. ठीक है? Very good. So tan theta is the height upon base. It is the perpendicular, which is I dash divided by x dash. Let's say this gap is very small. So you will have di by dx, which means the slope of this curve, slope of I and x is di by dx, the change in I divided by change in x. So when the slope, I am interested in maxima. So as you have seen this is the maximum height, है ना? This is the maximum value that I can have. Here, if you will draw the tangent to this point, it will be a straight line with zero slope, which means that di by dx equals to 0. Okay. So for any point, if you want to find out the maximum value, just differentiate that quantity with respect to the variable one, in which, in with respect you are seeing the variation of it. We are seeing the variation of I here with respect to x. So we would have differentiate this I with respect to x. Okay. So at the point of maxima, you will have zero slope tangent. Got it, Jhansi? Okay. Welcome. And you don't have to say thank you because it's my job to done, na? To make you understand each and every concept of the physics. Now, so this is the formula for, let's say, the differentiation. If a function of x is it is f dash x is fx by gx, and you differentiate it with respect to x, if y is equals to, let's say, if y is equals to this, so the differentiation of this would be denominator ka square, differentiation of first, and differentiation of numerator, d by dx of numerator, denominator as it is, minus differentiation of denominator, numerator as it is, in multiply. Okay. So same thing you have seen here. Here, this is a fx and this is itself gx. So if you would differentiate this with respect to x, you will have r square plus x square raised to the power 3 by 2 ka square. Hmm? Denominator square. Then the upper part, you have differentiation of this gmx. Gnm are constant, only x is there. So differentiation of x is only, it will give you gm, and r square plus x square raised to the power 3 by 2 as it is, minus differentiation of this term. So firstly it will behave as d by dx of r square plus x square raised to the power 3 by 2. So firstly you will consider it as a function, itself is a function, capital X raised to the power 3 by 2. Okay. Then differentiation of this, differentiation of x raised to the power n will be n x raised to the power n minus 1. So it would be r square plus x square 3 by 2 minus 1 into, again x square itself is a function here. So you will differentiate this term r square plus x square. R square is constant, it is the chain differentiation. R square is constant, so differentiation of this will be 0, plus x square you have 2x. Put this value, this 3 by 2 minus 1 is 1 by 2. So put this value in the above expression. It is r square plus x square raised to the power 1 by 2 into 2x and gmx as it is. Okay, and this would have to be 0 for I maximum. So this denominator term goes to the 0, vanishes itself. And if you solve this expression, you will have x is equals to plus minus r upon root 2. So at this point, you will have I max. Now what is the value of I max? Put the value of x is equals to r by root 2 in the above expression. So it is gm r by root 2 into r square plus r by root 2 whole square raised to the power 3 by 2. Okay. So it is gm capital R divided by this r square by 2, it will become, if you take the LCM, the 2 goes up. Now, if you take the LCM, it will become 3 r square by 2. 3 r square by 2 raised to the power 3 by 2 into 2 raised to the power half. Okay. This r square has power 2. This 2 will cancel out this power. Okay. So r square have a power 3. Let me write it here. I max here is gmr divided by this 3 by 2 will have the power 3 by 2. Okay. 3 raised to the power 3 by 2. 2 will go upside, raised to the power 3 by 2 into r raised to the power 3 multiplied by root 2. This r and r will cancel one power of each other, and you will have as this term. It is I max is equals to g m divided by, if you take this root 2 on the numerator, so 2 will have power half. So 3 by 2 minus half will become 3 by 2 minus 1 by 2 will become 2. So you will have 2 raised to the power 2, which is 4. So 4 gm divided by, it is root 3 to the power 3, because 3 raised to the power 3 by 2, you can say it is 3 raised to the power 1 by 2 into 3. So it is root 3 raised to the power 3. You can multiply it 3 times. So it will gives you 3 root. Okay. So this expression you will have as, just a second. So I will write it here. So I max finally you will have I max is equals to 4 gm divided by 3 root 3 into r square. Note this down. Okay. So this is the maximum value of intensity, which is comes at the r is equals to plus minus r by root 2. X is equals to plus minus r by root 2. Got it? And this is the expression. This expression is important. So note it down in your notebook. Imax is 4 gm by 3 root 3 r square. Okay. Yeah, Lakshmi. Tell me what kind of doubt you have. Just write this in the chat box now. So in this expression, if you guys having any doubt, you can write into the chat box. Okay. All clear. Very good. So today we will keep this lecture from this point. Okay. In the next class, we will discuss the uh, remaining portion, like the gravitational field intensity for disk and the gravitational acceleration, which is gravity, you will say. Okay. And the effect of gravity on by the shape of earth, and if you move up and down on the earth surface, from the earth surface, what will be the effect on the gravity, then all the points should be discussed there, will be discussed. Okay. Till now, if you have any kind of doubt, you can ask. Otherwise, the lecture is over. Thank you so much for being attentive. Okay. And I hope you are clear with this. Okay. So thank you so much, guys. Good evening. Bye bye. Take care.